Assalamualaikum. My name is Muhammad Nur Sufyan Bisude with ID MA18263. We are from BMM 3521 Section 3 Group 3. So in this video we are going to present for the experiment about Bernoulli principle. So I will present for the chapter 1. In fluid dynamics, Bernoulli principle states that the increase in the speed of fluid occurs simultaneously with a decrease in pressure or decrease in fluid potential energy. Bernoulli actually derived the equation from the first principle, which is Newton's law of motion. Basically, you look at the small volume of fluid and the force on the volume. If the pressure is decreased along the direction of travel, then there is no more pressure behind the in front. This is the schematic and equation Bernoulli principle. A practical application of Bernoulli principle is the venturi tube. The venturi tube has an inlet that narrows to a throat at constrict point and an outlet section that increases in diameter towards a rear. The diameter of outlet is the same as that of the inlet. The speed must increase to allow the same amount of air to pass in the same amount of time. When the air speed up, the pressure also decreases. Problem statement. In this experiment, there is variant of total pressure head, static head and dynamic head that required to investigate. Is that possible using venturi apparatus to vary the static head and dynamic head of the fluid flow through the volumetric tank? The objective of the experiment is first to determine the total pressure head of the fluid flow through the volumetric tank. Second, to determine the static head of the fluid flow. Lastly, to determine the dynamic head of the fluid flow through the volumetric tank. Lastly, the scope of this experiment. First, investigate the variation of total pressure head, static head and dynamic head. Second, measure the static head through multimeter manometer at the top portion of apparatus. Lastly, calculate the velocity of the fluid through the volumetric tank from the dynamic head. So I think that's all from me.
Assalamualaikum warahmatullahi taala wabarakatuh. My name is Ahmad Salahuddin Madin. My number is MA18242. And for this chapter 2, I will present about the theory. The next, for the theory of Bernoulli principle. Bernoulli principle of fluid dynamics states that an increase in fluid speed happens concurrently with a decrease in static pressure and decreasing of potential energy of the fluid, as an increase in fluid speed happens simultaneously within that step. So in this experiment, we were tasked with verifying and testing as well as applying Bernoulli principle of fluid flow. And as for the derivation of Bernoulli principle, is to sustain a constant volume flow rate, incompressible fluid must accelerate when they enter the narrow constricted section, where for the formula W external equal to delta K equal to 1 over 2 mvf square minus 1 over 2 mvi square. So as for the Bernoulli theorem, stated that when the flow is steady and continuous in an ideal compressible fluid, the streamline has a continuous sum of pressure energy, kinetic energy and potential energy. So for the pressure head, so for the formula is pressure head plus velocity head plus elevation equal to constant, where as you can see the parameter on the formula, where P equal is the pressure, Y is the specific weight, V is the linear velocity of flow, G acceleration due to gravity, and the last one is Z is the elevation from the data.
Assalamualaikum warahmatullahi wabarakatuh. My name is Afi Izzuddin bin Muhammad Nazri and my metric ID is MA18215. So I will talk about chapter 3, which is methodology. So the first one is the apparatus that needed to set up the experiment. So the first is pitot tube, then venturi tube, manometer, motor pump, water tank, stopwatch, pipe valve, single pitot manometer valve, And lastly is water flow control valve. Next is the procedure to set up the experiment. So the first one is the pipe valve, the manometer valve, and the water controller are all to be set up according to the provided diagram and properly, and each component are to be checked to be completely open while valve 2 is half open. The water pump is started by raising the speed of water flow from adjusting the water flow valve and the overflowing of water in the manometer valve and pitot manometer valve will remove any air bubbles from both manometers. Third, the single pitot manometer valve and manometer valve then are to be shut close. The pump is stopped and the pipe valve 2 was closed and pipe valve 1 remained open. Then the manometer valve and the single pitot manometer valve are to be open to allow airflow into the system. The pitot manometer valve and manometer valve are closed when cross half of the columns, then reopen, and pipe valve 2 is to be fully open. Starting from tubing 1 to tubing 6, the water flow control valve set to make sure the placement of all water levels in the manometer could be reached. The pitot head and steady head measurements in the venturi tube were recorded. Lastly, the flow rate was recording based on the volume of the water and the stopwatch used to monitor and record water tank raise.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Atira binti Abu Bakar. My matric ID is MA18188. For experiment 1, Bernoulli concept, I will present chapter 4, results and graph. Firstly, we have the result of this experiment. We have total of 6 points and we have the internal diameter, radius and area for each point. The volume of water is 5 liters and the time taken is 22 seconds. We then calculate the flow rate equal to 2.27 times 10 power of negative 4 meter cube over second. This is table 2. From the experiment, we have read the static head and pitot head. And from the calculation and formula, we get the head dynamic measured, head dynamic calculated, and the head total. This is table 3 and table 4. Table 3 shows the velocity measured and velocity calculated, and table 4 shows the pressure dynamic measured and pressure dynamic calculated. Both of these data came from the calculation of the formula. The details of the calculation will be shown on the next slide. This is the example of calculation and it is based on point 1 only. Firstly, we need to calculate the area of each point, which is A equal to pi r square divided by 1000 square. We divide by 1000 square is because we need to convert the millimeter to meter. Second, we calculate the head dynamic measured equal to head pitot minus by head static. So 200 minus 195 equal to 5 millimeter. Third, we calculate the velocity measured square root. 2 times g times the head dynamic measured is divide 1000. So we get the answer in meter per second. For we calculate the pressure dynamic measured, which is rho times g times head dynamic measured that has been calculated, and the answer I convert it to kilopascal, which is we get 49.50 kilopascal. The fifth calculation is velocity calculated. The flow rate is divided by the area, so we get the answer in meter per second. Then we calculate the heat dynamic calculated, which is velocity square over 2g. Then the pressure dynamic calculated, rho times g times heat dynamic calculated. Lastly, we calculate the heat total calculated by adding heat static and heat dynamic calculated, and we get the answer in millimeter. All of this calculation, we will transfer it to the table that I have showed earlier. This is the graph for this experiment. We have total of 3 graphs. Firstly, we have the total heat and heat dynamic against point. Next, we have velocity versus point and dynamic pressure versus point. Each of the graph based on 3 tables that I have showed earlier. That's all from me. Thank you.
Assalamualaikum. My name is Amirul Ashraf bin Abdul Rahman, metric number MA18257. I will continue on the discussion of the experiment. First, this experiment aims to test the validity of Bernoulli's equation and also the variation when applied to steady flow water in the tapered tube. These experiments apply the equation of Bernoulli's principle, which is P1 plus 1 over 2 rho V1 squared plus rho GH1 equal to P2 plus 1 over 2 rho V2 squared plus rho GH2, where this equation relates the pressure, velocity, and height of any 2 points, which are point 1 and point 2, in steady streamline flowing fluid. This equation relates to conservation of energy principle appropriate for flowing fluid. According to Bernoulli's theorem, the lower the pressure, the faster the rate of flow, and the higher the pressure, the slower the rate of flow. So in this experiment, we may find that when the diameter of tube is decreased, the flow rate will also decrease, resulting the increase in flow velocity. So the increasing flow velocity will decrease the static head and increase the dynamic head. The results and graphs obtained in this experiment has satisfied the Bernoulli's principle. Also in this experiment, we may find that there is a small variation between measured and calculated velocities. As a result, loss in pipes due to pipe friction reduce the accuracy of the reading. The measured velocity differs from the calculated velocity due to parallax error, environment error, systemic error, or random error. I think that is all for discussion of this experiment. Thank you.
Assalamualaikum. My name is Muhammad Faisakil bin Ahmad Fuad, and my metric ID is 18186. So I would like to talk about the conclusion for this lab. In this lab, Bernoulli's theorem is shown to obey the equation as a result of the experiment. We may deduce that it is accurate for fluid flow based on this. As the segment's area shrinks, velocity increases and the pressure decreases. The experiment also demonstrated Bernoulli's theorem of energy efficiency in the streamline. There will also be inconsistencies as a result of this experiment, resulting of inaccuracy in the data obtained, random error, as well as variables not used in Bernoulli's equation, such as the points being slightly off kilter, contributed to the error. As a result, they won't perfectly align around the same axis. Since the fluid and rigid surface are in contact, frictional losses arise. I think that's all for our group. Thank you.